That's where we are starting. And so the thing I'm going to point out to you for 3-9 is that theorem right there. And basically all this theorem is saying, there's a bunch of math vocabulary and stuff, but all it is saying is if I have x to the fourth, I have 4 solutions. If I have x cubed, I have 3 solutions. If I have x squared, which is a quadratic, we have 2 solutions. So if we look at a quadratic and it looks like that, how many times do I cross the x-axis? 0. But our theorem states that I would need to have 2. So I would have 2 complex, because I'm using imaginary numbers, roots. Now you could have 0 imaginary solutions, and then you would have 2 real solutions. So they go in pairs. They go either 2 or 0. Okay, that's what we're looking at. That's all we need based on the theorem. How many solutions should we have? And we need to know how many solutions we should have, because all we're going to do for the next 3 days is solve. And if you solve and you go, Nichols, I got the answer. The answer is 7. I'm going to say and if you go, oh, that's all I got, well, you gave me 1 solution, we need 2. So every single problem that is quadratic, we are going to have 2 solutions. Now, we have 3 forms here. We have factored, standard, and vertex. We're going to solve all 3 of those forms. I'm going to show you the most efficient way to solve them. However, if it's in vertex form, you actually know how to change that to standard form, and you know how to change it to factored form. I'm not saying it's going to be easy, but you know how to do it. So you could change forms. I'm not going to show you how to change forms and then solve. I'm going to show you how to simply solve given the form that we're given. Okay? Some are easier, some are more difficult. First thing you got to do though is you got to write these out. And if you don't know them, they are in your notepad. Flip, find them. You're either writing or you're flipping. I would flip all the way to 3-1 if I was you. If you don't know them. If you do know them, start writing them out. All 3 forms, factor form, standard form, vertex form. What letters do I use for factor form? X minus R. Now, what does every single form have in common? They all have X's, yeah. They also all have A. That is the only coefficient that every single form has. That's also the coefficient that tells us, does this quadratic open up or does it open down? So it gives you a lot of information no matter which form you're given. Now, the thing is, quadratic formula, I've said it once, so I'll say it again. It works every time. You can always solve using the quadratic formula. But the quadratic formula uses A, B, and C. So if you're in factored form, you would have to change forms to use that. If If you're in vertex form, you would have to change forms to use that. So it's not always ideal to solve using the quadratic equation, but sometimes it works out nicely. Okay? So just food for thought on that one. Now, I'll draw it on the board here. That's the quadratic I have. Now you can't tell me what the coordinates are because I don't have any tick marks or anything like that. But you could tell me the y-coordinate. What's the y-coordinate for both of those? 0. So when this is telling me, okay, find the zeros, when it's asking me to solve, when it says find the zeros, find the roots, find the x-intercepts, okay, if it says find the x-intercept, then we write our solution as a point. If it says find the roots or find the zeros or find where this occurs, you're just finding x. But we know that the y-coordinate is going to be 0. Then that means I'm going to rewrite my equations with 0 in for the y-coordinate. So I'm plugging in 0 for my y-coordinate. I do that every single time. So what I want you to do is rewrite 1, 2, 3, and we're going to do this all day long. Anytime we solve, you put 0 right here. Because if I'm looking at what does x equal, I know that my height is at 0. So that's the first thing you do is just write 0 equals all that stuff. All day long. So you go ahead and write that, and then we're just finish off these 3 pretty quick. You're normally very good at these ones. All right. I think I've given you enough time for that. If I look at number 1, if I ask you what is the x-intercepts that this is given, going back to chapter 2, what would my x-intercepts be? -5 and +4. So since I'm solving this, I actually just write down x equals -5 and x equals +4. That's my solution. I am legitimately okay if you jump from that to this. That's the amount of work I require for something that looks like this. However, if you're going through a test fast, and you're like, sometimes I make mistakes, you can absolutely show work and guarantee yourself at least half a point if you start this right. So I'd write this equals 0. Remember, that's what we're doing. And then this equals 0. Okay? And then I would solve. So I'd -5, and I'd +4. That's why we have our solutions. Again, I'm not writing these as points because I'm only asking for the x. Any questions? Yeah.
Why don't you have to distribute for 2?
Perfect question. I was waiting for someone. I even left some space down here for that. And that's because of this. If I'm solving this, the first thing I do is I want to get my x's as isolated as possible. What's 0 divided by -2? 0. So now I have 0 is equal to x plus 5, x minus 4. So if there is only a number out there, it has no effect on the problem if we're just finding for x, if we're just solving for x. Does that make sense? Okay. What would be my x-intercept for number 2? What? Is that my solution? Put a box on it? What?
0.
And 0. Good. This one, put a star by it. Most forgotten solution out there. Okay? So these are my solutions. I'm going to break that down. Notice the difference here. So 1, I have a -2 out in front. For 2, I have 3x. So this time, I actually go 3x equals 0. I can think about that as being in parentheses. I can think of that as dropping that down and being like, okay, so I have 3x equals 0, then what the heck does x have to equal? Well, 3 times 0 is 0. You can divide it if you want. you get the same result. But yeah, that's the most forgotten one. People forget it in chapter 2. They forget about it in chapter 3. They forget about it in chapter 4. And even in 5. So please don't be one of those people. Easy points. Easy points. And this last one I do require some work. So I'm okay right here. Tell me what that 0 is. X equals positive 1. I'm good with that. This one, though, I want to see work. And I want to see work because I always see people either flip signs or flip the fraction. You get pretty good at it. You know kind of what the heck is going on. But we always make little mistakes, and those mistakes cost points. So we want to make sure we're watching out for that. So I get 2x equals negative 3, and I divide by 2, and so I get x equals negative 3 over 2. Love fractions. Leave it as a fraction. It's a simplified fraction. It's good. So you always got to remember, what the heck am I actually doing? If I'm finding an x-intercept, I'm really setting those two things equal to 0. So this is factored form. This is solving. What questions do we have? Then I want you to do number 4 and number 6. And they're both a little bit unique. So write it out. Take a moment. Get used to it. 4 and 6. Zero's always there because you're solving for the 0, which means you're solving for x-intercepts or when it has a height of 0. So the height is always 0 when we're solving. Alright, as I'm walking around, I see a lot of us are good at like one or the other, but we're not necessarily getting both. So we're going to just go through both. So again, I'm putting 0 here because it has a height of 0 at that point. So the y-coordinate equals 0. So I'm going to have 1/4 x. And then I'm also going to have 0 equals x minus 7 over 2. I don't even care what that fraction is. You just move it. Okay? So this is going to be plus 7 over 2. And so this I can multiply both sides by 4, and I get 0 equals x, and I get x equals 7 over 2. 2 solutions. And I even purposely wrote this one as 0 equals x because I don't care which way you write them. Alright? They're fine. I like to write them always as x equals the number, but it doesn't need to be like that. Now this one, a lot of you did a nice job of saying this equals negative 3. The tricky part is on this next portion, when I have 3 minus x equals 0, I minus 3 to the other side, which a lot of you recognized, but then that gives you negative x equals negative 3. So if negative x is negative 3, positive x is positive 3. And one way to algebraically solve is divide by negative 1. And so I get x equals 3. So I have 2 solutions then. I'm going to talk about 5 really quick. So I'm going to write it like this. What do I get it as a solution? 7. So I would put x equals 7. I do not need you to write that twice. I know you have 2 blanks there. What we need to understand is that we have the same solution, and it happens twice. So I have 2 solutions. However, the solution is the same, so I can write it once. Does that make sense? We have the same solution happening twice. We're going to go one step further with that. So I have a dot right there. I have a positive a. What does this quadratic look like? Go up, but what is that point? It's the vertex. Yeah. So this is actually my vertex. And it's because two solutions happen at the same point. Any questions before we move on? So that is factored form. Okay? Factored form, I would say, is the nicest form to solve. Okay? Every year we give a problem that looks like one of these, or even like one of the 1, 2, 3, one of those. And every year I have someone trying to distribute and do all this fancy stuff with it. Please do not. Please just take the parentheses and solve. Okay? Easy points right there. All right. Write this down. So change to the equivalent, right? So I'm still solving. I'm still saying this equals 0. I'm going to write something off to the right-hand side. Or to the left-hand side. I don't want you to write anything down. Okay? Just write what's over there. Print it on the screen. That face. You're looking at that with a little bit of disgust. Honestly, folks, vertex form are like my favorite to solve. I think they're the easiest. They're kind of long, but the process is really easy. Okay? We just have to understand what are we actually doing when we're doing that process. So, you've solved problems for quite a while now. What do you think would be your first step to getting x by itself? I don't care if you're wrong. Throw something out there. You know what? We can't do that right now, but we are going to do that. Okay? We will do that at some point. So that's good. What else are we going to do? Put 12 to the other side. So you threw out there, we're going to pause on doing the first step. Moving the 12 to the other side is good. If you think of distributing, I don't blame you because we've done this a lot. What happens if I distribute? What's the end result if I get all the way through there? I distribute, I add the 12. What have I done? We've made the problem bigger. That's kind of true. It ends up condensing a little bit. What are we doing if we're doing this? You're changing forms. You're changing forms. And that's not a bad thing. You can change forms. But like I said at the beginning, I'm not going to show you to change forms. I'm going to show you the quickest way. Now, you will be asked to change forms on the test. Don't confuse that with solving. Okay? So I'm really glad you brought that up. All right. First step. Minus 12 to the other side. Please be diligent about your notes right now. If you've been sleeping at all, you probably could survive, but this one's tough to come up with on your own. So, I've done this. Move the 12. What do I do next? Can't square it yet. What's there yet? Hold up. We're actually not going to distribute. We want to get rid of it. How do I get rid of the negative 3? Divide. So I'm going to divide. And I get 4 is equal to x minus 5 squared. So now we're going to deal with the square. To get rid of squares, we square root. Okay? And we always do that to both sides. So we BS the problem. Now, what's the square root of 4? We all in agreement? It's 2? Yeah? So the last thing I do then is I plus 5, And I end up with x equals 7. How many solutions do we have right there? Ooh, we need 2. The fundamental theorem of algebra. The thing that this whole class is kind of like built on says we need 2. It is plus or minus. So folks, anytime that you introduce a square root, anytime that you decide to add one to the problem, you get a plus or minus sign. So when you do the quadratic formula, it's part of the formula because we introduced a square root. So it needs to be there. Now, to make that crystal clear, if I have 2 squared, what do I get? If I have negative 2 and I square, what do I get? 4. So I need to account for both the positive and the negative. So now, this is half right. We break it apart, we go the other way and say, okay, I have negative 2 equals x minus 5. And so I'm going to put plus 5 and plus 5. And I also get x equals 3. I now have 2 solutions. What questions do you have? Thoughts, wonderings? You gotta at least be wondering something. What about what's on the left? Nichols, why did you spend your time writing all these parentheses in there? Let's think about that. So, I'm backtracking. Now, that right there, this problem, is like an onion. And onions are like ogres. Oh, whoa. What movie am I talking about? Shrek. We call this the Shrek method because these problems are just like an onion. Just like an ogre. They look all nasty on the outside. But when you start breaking them down, piece by piece, they become this beautiful problem. I mean ogre. Okay? So every year, I kid you not, this is 4 years in the running, one kid during the test sees the Shrek method, and he goes, donkey, and then he like looks around, and everybody looks at him. And then I'm just like, every year, why do we do this to ourselves? Without fail. One person. All right? So, I don't know, maybe you want to be that person, maybe you don't, but every year, somebody throws it out there. So again, vertex form. On your test, we actually throw up there. It's a vertex form problem. We even put Shrek method as a hint. Okay? So just think of the lovely ogre where all of this stems from. Okay? All right, number 2. First step that I always do, I replace this with 0 because I know that I'm solving for my root. Now that I've done that, you're going to talk me through it. Let's peel the layers away from this onion. What's the first layer of onion that gets shredded? Yeah, we're going to add the 10. You can almost hear the soundtrack. See what I did there? No, I'm just kidding. All right, you can almost hear it like in the back of your mind, like we peeled one layer away. You can hear the music from Shrek starting to beat out. What's the next step? Multiply it by that -2 or negative, yeah, okay. So we're canceling this fraction. So we multiply that by the same thing. We got one more layer of that onion going away. You can almost see his big beating heart, that nice ogre. So we got negative 20. Yeah, we multiply by negative 2. And you can say that you're dividing by negative 1/2. But if I got negative 10 here, what do you do with fractions? You keep, change, flip. So this would be negative 10 times negative 2. So I'm going to erase that. Now, we are just full of the movies today. And so, Shrek makes an appearance. We actually just kind of dissect that onion, the whole class. But now, what do? We're going to have another character showing up here in a moment. Take the square root. We put a plus or minus out in front. What's the square root of negative 20? Oh, whoa, 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 whoa. Don't even touch those calculators. Put them down. We don't use calculators for square roots. We can, kind of. What were you going to say? Oh, yes, we can. We have to use I. Yeah, if you don't use an I, Jack Sparrow comes looking for you. I know. All right. So now we not only have plus or minus, we are going to throw an I out there. Now I'm going to pause that. I'm going to erase that. So I'm doing all these steps going down, and then off to the side, I now throw in a little thought bubble. And so on this thought bubble, I put the square root of 20, and I'm putting I outside. Okay, so we got this. Give me two numbers that multiply to make 20. 10 and 2, 5 and 4. Why am I going to skip 10 and 2? Do you know the square root of 2? Do you know the square root of 10? No, you would have to keep going. So I know 4 and 5 is really nice, so I'm going to choose 4 and 5. You can absolutely use 2 and 10 though. What's the square root of 4? 2. So I draw a little line through that, put the 2 out there. So down here, I'm going to have plus or minus 2i square root of 5. Now folks, anytime that you have a square root of a number you can't take, or you have an imaginary number, you should be happy. Because it actually makes your problem a little bit shorter. It actually makes the steps just that much shorter. So this is going to be x plus 1. Now, I subtract 1 over. Can I combine those two things? No. So I end up with x is equal to negative 1 plus or minus 2i square root of 5. That is your answer. So, you know, we started with this very ugly ogre, and we came up with this very beautiful solution. It might be imaginary, but we can still see the beauty. Okay? So, that's what we got right there. This is why I say that it's easier, because if you look right here on minus 1, on this last problem, we got down here, we actually split it into two different formulas so that we could solve the positive and the negative. But I don't have to do that if I have an imaginary number or I have the square root. Okay? Now there's one other thing that I want to talk about. Dealing with square roots. I've thrown all my markers everywhere. I can't even, I'm going to do it on the board actually, so it's in the video. So, when we gave you the square root of negative 20 in 3/6, we asked you to simplify that radical. You looked at it and you gave me this answer, 2i square roots of 5. Why did I not make you put a plus or minus in front of that? Were you given the square root? Yes. Okay? We did simplify. We simplified the radical form. Okay? We were given a number. Here, I introduced it. So if I introduce the square root when I'm solving, I need to have it. if I'm simply simplifying a number, you don't get a plus or minus sign. You just have that one number and you're simplifying that one number. Okay? Does that make sense? All right. 4 minutes. Work together. Work alone. Do what you can. Solve it. How many solutions do I have on the board? No.
How do you get your answer
So
yeah, but like
negative makes that positive.
once you get to like that,
Give me two numbers for that.
5 and 2.
Okay. Can I break them down any further? Can I take the square root of either? Then I just put them back together. And I leave it at square root of 10. So if you got the square root of 15, it's actually going to stay as that because that would be 3 times 5. Right? You don't have a pairing that you can take out. So if you cannot take out something, you don't. You leave it. If you give me the decimal approximate of that, wrong. Okay? I want that radical. We will not accept points for the decimal approximate. Any questions? Y is the 10, square root of 10?
Yeah.
Well, it's not positive. You're just saying the 10 inside.
Yeah.
Because that negative became that I. So you're not allowed to leave that as a negative. You have to take the I out. So the I can always come out. The 10 in this case. That's a really good question. Any other questions? All right. The And what I want you to do is I want you to have your homework packet, working on that, and I want you to keep your note packet up. Okay? Because it's going to be helpful to have those steps. Problem for problem, they help each other out.